Good evening, everyone. Good evening, everyone.
Good evening.
There we go. Thank you all for coming. Welcome to this month's ClimateLink event. My name is Rodney Mickelson, one of the organizers of ClimateLink. And for those of you, well, let's see, who is here for the first time? 1, 2, 3, 4. Okay, good. Well, welcome. So for those of you who don't know, we do these events monthly. Sometimes we have more than one a month. And what we try to do is showcase new technologies that are coming up that help fight climate change. And so we cover everything from building efficiency to water technologies to electric aviation and battery chemistry, all the way up. And we also do things for startups, like with help with fundraising. We covered fundraising a couple months ago. And at the end of the year, we usually partner with another meetup group called Data Science for Sustainability, get a big name person to come and speak, and then have a party to celebrate what we've done. So real quick, we've eaten some food and we've talked to each other. Now we'll do announcements. Then we'll get to the reason why you're here. And then we'll eat some more food, talk to some more people, and then we'll go home. So real quick, I want to give a shout out to Pete Shoemaker, who is our host from pg&e, and he'll tell you a little bit more about the space and what to do in case of an earthquake.
Good evening. We have a brief safety announcement. If things start shaking, get under the table, grab and hold. If you have to exit the building, out those stairs here. Also, you can go back to where you came, half a block down to 4th and Howard, and we'll collect there if necessary. All the staff is well trained and CPR certified, so any emergency, just follow our lead. Bathrooms are on the back door there, as you see against the wall. There's extra bathrooms down under the stairs on the first floor, and everything goes into either the compost or the recycling. There's no trash in this building. We don't do trash anymore. So welcome. How many people of you have not been to this building before and didn't know about the PEC? Great. That's exactly what we want to happen. We get new people into the building. We'll give you a quick promo about why this is a great resource for you. Talk a little bit about some upcoming things very briefly. This is a ratepayer-funded facility that has classes and tool loans for all types of energy. Classes in solar, building design, exactly what's going on here. Actually, one of our instructors, Ryan, I'll introduce him in a minute, just talk in the back room, who's going to partner with the Keewi people on a project using our tools and sensors and things like that. So we have a remarkable array of classes. We have calendars just down. We have, of course, an online calendar, but we do have a printed calendar. They're up here free. Help yourself. We also have, again, an extensive tool lending library downstairs with all kinds of tools. Some of them very expensive. We have experts on site to help you figure out what tool you want and get it. So I'm the solar instructor here. I want to introduce my colleague Ryan Stroop, who is the building performance, commercial building and commissioning person here. He's going to tell you a little bit about a special event that he created coming up on October 10th.
Thank you, Pete. And actually, when Pete says things are publicly funded, we just translate that. That means they're free. So everything we do here is free to you. It's actually been paid through your utility bills, the classes, the tools. You can borrow a $10,000 ultrasonic flow meter, and who wouldn't want to borrow an ultrasonic flow meter? You can borrow that from our lending library at no cost. So I wanted to tell you about an event that I have planned, this be noted, on October 10th. We did this in the spring. We did an energy trivia night. Robbie was here. I thought it was great fun.
Yep.
And I'm doing that again with different trivia questions on October 10th. So I encourage you, you collectively could create a very formidable team for Energy Trivia Night. We'll also have food and it'll be a networking evening. So, and I think it'd be a good learning opportunity as well if you're new to the industry. Free event, October 10th.
We'll post it as a meetup so that we can sign up and then create teams.
Thank you.
Anything else? No. All right. So if you want Wi-Fi, you can connect to Gecko, and then the password key is the long string of numbers. So a little bit more about ClimateLink. We're trying to build the largest clean tech network and create all these network connections between the nodes so that we can accelerate capital deployment and accelerate development of these technologies and save the planet. So we've got Slack, we've got a YouTube channel, we've got a monthly newsletter. So we announce our meetups and other events in the newsletter about a week or two before we announce it on Meetup. So if you want early access, you can go there. We also post fundraising announcements and other fun events. So next month, we're doing an event on women in climate leadership. We'll also be gathering for the energy trivia. And people have jobs. Some people want jobs, some people have them to offer. We like to help them come together. So first, who here is looking for a job? Okay, this will be fast. We've got one person looking for a job. Who here is offering a job? Sam.
Hi, I'm Sam from Gaza. We're hiring for several roles. There are more than 1 billion people around the world who don't have access to functioning electric grids or banking services, and they use filthy, polluting, obscenely expensive kerosene to light their homes. Businesses are competing to replace that kerosene with solar power because it is so much better a deal. We help them. We need a vice president of customer success for this wild capitalist ride to make clean energy available to the people in the world who need it the most. So come talk to me about that, or go to angaza.com, look at the other roles we have available, and come talk to me about them also.
How do you spell it?
ANGAZA.com. Thanks.
We'll just go this way. Anybody else? Jobs, Mark.
I'm Mark. I'm a data scientist for WeaveGrid. WeaveGrid is a fresh new startup. We just hired our first engineer, and we are hiring a couple more, at least one more, maybe two. Mainly focused on the platform back-end side, but also potentially on the front-end side. And WeaveGrid is working with utilities to help them manage electric vehicles on the grid. So if you want to learn more about that, you can go to WeaveGrid.com or talk to me.
Fine.
Hey, I'm from Touchlight. We're hiring a data scientist and or anyone with machine learning experience. We provide a subscription that covers all your energy needs for homes and C&I sites. So if you want to learn more, come talk with me after.
Okay, I guess that's it. So without further ado, I want to wake up Hedi Razavi, one of the co-founders of KEEWIAT. Oh, and an update, Carbon Lighthouse had to not come at the last minute, so there's an opportunity to have another discussion if somebody has a building performance technology that they've been working on and just dying to show it off. You'll get that chance too. So without further ado, Hedi. There we go.
All right, thanks Ravi for that introduction, and good afternoon, good evening everyone. Thank you for having us. As Ravi mentioned, my name is Hedi Razavi. I'm here with my better business half, Jennifer, in the background. She's the one with the Keewi t-shirt. So yeah, thanks for being here. Also a shout out to pg&e and the center. We've actually spent a lot of time here. I personally have taken some of Ryan's classes, and they're great when it comes to building systems. And we have utilized the tools in the library quite a bit. So we're actually about to pick up some occupancy sensors after this from downstairs. So it's a great resource. Definitely encourage you all to take advantage of it. So thank you for hosting us. We actually did this. We were able to present here about exactly 2 years ago, Ravi. I was looking at our notes, and it was exactly September 2017. So it's good to be back, and it's good to be able to give an update. So maybe just as a quick set of introductions, Jennifer and I started Keewi about 4 years ago now, and it's hard to think that time flies so much so quickly. We started Keewi with the notion of wanting to have an impact on really the biggest problem that's going on right now, and that's climate change and all the environmental problems associated with it. We both have backgrounds in wanting to make a difference. Our motto is essentially blue skies and starry nights, and so that was the impetus behind starting Keewi. And when we started looking at where we can have the biggest impact, we realized that when it comes to the energy use, when we look at the energy use of commercial buildings in the US specifically, there are three main categories of energy use that can be thought about. What most people think about are sort of HVAC systems, the ventilation, air conditioning, cooling, and heating systems of the building. And traditionally, those have been the biggest draws of the energy use. You also have the lighting system. Most people are now familiar with LEDs and how big of an impact that has had from an environmental perspective as a new technology, which is great. And then there's a third category, which has traditionally been ignored and forgotten, not because it's not a big problem, but because it's a hard problem to solve. And we set out to address that problem. So that comes with, what I'm talking about is essentially the energy use of all electrical appliances that get plugged into the electrical outlet. So when you look around the building, you see electrical sockets all around you. Every almost 6 to 12 feet, by building code now in California, you have to have sockets, and there's a big amount of energy draw inside buildings that goes through these sockets. Unfortunately, these particular building assets, if you think of them as such, are not being monitored in any way. And when it comes to building systems, Ryan and probably Pete can tell you that there's a big saying that so the infrastructure for making measurements on what is getting plugged in and who's using it and how much is getting used and whether it needs to be using energy at any given time or not does not exist. Right now, all these sockets are passive sources of electricity that essentially can bleed electricity out without a way to have a stop to it. And that's really the big problem that we're trying to solve here. So in our relatively short company history, we are very proud to have worked with a number of leading institutions. We started out our work with San Francisco Airport as our very first deployment, continued with Stanford, and the list has been growing ever since. What's really exciting for us to report, especially this year, has been our work with larger organizations like utilities. So we have an agreement with a utility excuse me, an energy retailer in Australia called Energy Australia, and I know we have an Australian in the audience, so Katie probably recognizes that name, not to put you on the spot. But we're also doing a really exciting project with a utility company out in the Midwest, and it's wonderful to see now our approach and our technology being applied at a much larger scale. So proud to have worked with these folks, and would love to tell you more about them as part of the conversation today as well. And by the way, I just realized this is meant to be a discussion. So if you have questions along the way, feel free to raise your hand, and we could definitely.
Hedi?
Yeah.
Not a question, but so when Jennifer presented 2 years ago, I was remembering back. So you had Stanford, which was basically your lab. It's like, okay, we put this in our office and then tested it, and then you had SFO. And so in the 2 years, you've added everybody else. So that's awesome.
Yay! Yeah, it's been a big change since then. Thanks for recognizing it. Yes.
And how did you acquire these customers? Like, are they soliciting proposals for the new technology, or they're doing retrofits and you're able to piggyback off of the prime contractor? How does that work?
Yeah, essentially all of the above. Each of these logos has a pretty interesting and unique story, but at a high level, there is the recognition from a lot of building managers and building owners looking at their energy and electricity bills and wanting to have a difference and have an impact and have a solution for what they're doing. So for example, the Los Angeles Unified School District, their energy bills are going up by 5%. Their energy rates are going up by 5% annually, year by year. And they have done most of what they can do when it comes to HVAC and lighting systems. They have LED deployed in most of their schools. They have 1,000 schools. They're the second largest school district in the US. And they recognize that the problem with plug loads has not been addressed, and they haven't been able to look for it, or they haven't been able to find a good solution. So they've been looking for it. And so a lot of these customers come to us because they know that the electrical sockets are a growing problem for them, and they need to address it. They just haven't been able to do it well yet. Good questions. So as part of our introduction, I also wanted to share with you all that while we care about having an impact on the environment and putting an end to the energy waste, we also have a philosophy at KEEWI that in order for any sort of new technology or approach that's environmentally oriented to be effective, to be scalable, and to have a positive impact, it actually needs to make good business sense. In order for businesses, companies, individuals to start making the choice, it has to end up being the right choice and the right decision for people to adopt it. And so with that in mind, we have always kept that in the back of our minds as we have developed technology and solutions to address this problem. So we have a vision at KEEWI where we imagine a future where the electrical sockets are no longer the passive sources of electricity like they are right now, but rather they're actually powerful sensors that can help to make buildings not just more efficient, but also more comfortable, more convenient, and safer. And this has been our guiding vision for what we've done so far at KEEWI and where we're headed from here on. So on the left, we talk about the electrical sockets and where they are, in that there's such a massive scale of them. There's so many that makes their management difficult. And at the same time, we believe that they have a potential that has not been realized yet. And the tomorrow that we imagine is that these things are sensors that can help bring eyes and ears to the building, giving building managers and building owners visibility into what is going on inside their building. So in our journey, what we have found out is that plug load energy efficiency, which is what we have been able to prove over and over again, bringing 20 to 40% reduction in energy use of the electrical sockets, and essentially eliminating the energy waste, is really just the tip of the iceberg. Because using the data that is collected at the outlet, imagine each of these things becoming a sensor. That data in itself can help businesses from the perspective of providing information about space utilization, how their assets are being managed. They can also help, obviously, from an overall building efficiency, and it maybe even bring comfort for the employees. So that is our long journey ahead. We have been making progress towards this, getting closer and closer to the edge at the bottom, and I'm excited to tell you more about all of that. So you may ask, okay, how does this all work and what's involved? So we'll spend a little bit of time talking about the technology and the solution itself. So the first and most basic thing that we do is to essentially upgrade existing outlets. We use adapters that look like, they look like, commodities like this. These are smart outlets and plugs. I have some examples up here. We can install these inside commercial buildings or even residential. And compared to existing sockets, they have two main capabilities. One is that they're able to be turned on and off. So you can imagine that we now have finally a faucet on the electricity at the outlets. We can finally turn them off and prevent waste of electricity. So that's the first thing that they do. But secondarily, and probably more importantly, is that they're able to collect data. And so we are able to continuously collect energy use data in the form of current and voltage as a function of time. So it's a pretty simple time series data for the data scientists out there. And we have been extracting value from this data stream. Care about electricity use of your office. Good, this is the good audience. And in the general population, there would be a lot fewer hands going up in the air. People typically are not aware, and they don't really know what's going on, and they feel like they can't do anything about their office environment and their settings. We changed that. At KEEWI, we give them, the occupants, the power to manage their own footprint using their appliances. They can set up, for example, they can turn on a feature we have called Toggle AI that learns over time how a particular piece of equipment is getting used. So, for example, if you typically come in Monday through Friday, and you have a pretty consistent schedule, showing up around 9, leaving around 5, you can tell our system that, hey, I trust you, and you can turn off my appliances when I'm not here. And our system learns over time and predicts for any given 15-minute interval what's the likelihood of you needing to use the sockets. And if you do, then it's on and it's ready for your use. And if you're not there and there's a higher likelihood that you're not using it, then it automatically turns it off. So you, as the user, would not have to worry about doing the right thing. KEEWI does that for you automatically. Yes?
So you mentioned just office spaces, but I'm more interested in like more complicated buildings, such as labs or hospitals. I mean, hospitals are totally different code section, but like SFO airport. Like, what was the project with the airport you did?
Yeah, good question. There, of course, you're right. There are a lot of different building types. So we have experience a lot in office settings. So the project at SFO, for example, is the net zero building that before we started there was actually utilizing 50% more electricity than it was modeled to. And there was a big question and a big hunch essentially in that, okay, probably it's the plug loads that's actually affecting this mismatch. So so in that setting, it was it's a 24/7 use case building specifically for the building for the airport operations. It's not the terminals per se, but of course terminals would be more of a complicated building. So going back to your original question, it really would require adoption of the technology for the specific use case that we have. A lot of our experience has so far, as I mentioned, has been in the office settings as well as residential settings, for example, like university housing. So that's an area that we're continuing to learn more about. With labs and hospitals, it's very special, and so we're developing technologies to be able to handle the special requirements there as well. Yes?
How has the difficulties that PG&E had pushing out smart meters, a lot of public discomfort and all that, how did that inform your approach?
Yeah, that's a good question. So in the recent project that we're doing in the Midwest, we've actually heard that from a few folks in that the notion of smart plug or smart meter is something that people may be wary of. And our philosophy and our understanding is that there are always all sorts of people. You can't satisfy everyone, but there's a wave of awareness and understanding and acceptance of all of us needing to take responsibility for climate change and wanting to do the right thing for it. So we believe in pushing forward the limits, and the social systems and networks will follow. That's our belief. Oh wow, lots of hands. Go ahead. I'll just go.
First one is just like a pretty basic question. Do plugs that have nothing plugged into them drain? Is there a loss on a plug that's just sitting in a wall?
A socket that's not plugged in, no,
Nothing,
there's
okay.
nothing there.
So-
But
okay.
when you have, there's a thing called vampire load.
Yes.
And that is, for certain types of appliances, if you have it plugged in, yet if it's not on, it's still continuing to draw power.
Right.
And that would be part of what we would be able to eliminate essentially.
Can you do that in a responsive way? Like if I have my iPhone charger plugged in and I plug in and now it's fully charged, can you then sense that and turn it off automatically and then turn it back on when the battery, like if I unplug my phone or something like that?
Yeah, we did that with laptops. Laptops tend to have a higher draw, so it's easier for us to be able to sense that distinction. But assuming that the capabilities of measurement for the meters that we have allows for the iPhone, it could also be applied to that. Okay, there we go. Yes.
Do you use the appliance data to like look at its performance? You see if like, is the fridge door left open or maybe it's failing or something like that?
Yeah, I love that you asked that, and that really goes to the asset management sort of side that we're talking about, being able to do failure detection and fault detection way before a piece of appliance actually failed. So happy to share more about that down the road. Yes.
So is this like a monthly subscription that a building manager would subscribe to control like this many plugs a month?
Exactly. So we're trying to make it easy for building managers to adopt the technology and to start using it and integrating it with their other building systems. That's our goal, and that's what we're working towards.
What's the question?
Maybe we can go to the end and then come back. Yes.
Hedi, can you repeat the questions too,
Oh,
so make sure?
Oh, sure. Yeah. Good point.
I was wondering if it's mainly for companies or you also sell to private, like is it B2B or
About 90% of our business so far has been on the commercial side, so primarily B2B. We have also worked with partners on the residential side, and we hear a lot from people wanting this for their homes. We are still a relatively young company with a small team, so having a consumer-facing product, of course, is a whole new layer of challenges. But we have worked with partners, and that actually is part of the impetus for wanting to work with utilities in scaling that up to bringing that to consumers at the end. Would you be interested in having it in your?
Sure.
For sure? Okay, cool. Let's talk afterwards then. All right. You had a question?
That was actually my question.
Oh, nice. Okay, you guys coordinated. Okay, coming back this way. Yes.
Yeah, I was just wondering if, like, you manufacture your own plugs. And actually, I have a second question related to that. The gentleman asked earlier about, like, the vampire load. I assume, like, if they're using Wi-Fi, then there's going to be some load from the smart plugs themselves, even if something's not plugged in. But, yeah, I was just curious about that.
Yeah. So at Keewi, we're primarily a software company. We don't manufacture the hardware, although we can tell you anecdotes about Jennifer and I when we were first starting out wanting to make the hardware ourselves, and took some time to realize that it's probably best to use existing off the shelf, so why reinvent the wheel? One of the best decisions we've made. So we don't manufacture these things. We've established partnerships with 5 vendors now and counting, and we're able to provide all sorts of different form factors, single socket, dual socket, retrofits like this where you don't have to replace the existing socket, or we also have in-wall version where you just completely replace it so that there's nothing protruding from the wall. They're essentially a commodity with probably 100 different companies making similar types of equipment. What they've all, unfortunately, where they've all stopped, and because they're primarily hardware, is at best what they do is display the data, but they don't go beyond that, extracting value from the data, which is where Keewi's sweet spot is in looking at the data and extracting additional value from it, giving insights about people and spaces. And I think I'm sorry, you had a second part to your question in terms of it actually.
In terms of vampire load, there's going to be some from even like from the smart plug itself if it's not, but it shouldn't be too significant, right? Even if there's nothing plugged into the wall.
Yeah. So for the ones that we use, that's actually one of our requirements. The load that the plug itself provides is 0.5 or 0.05 watts. So it's very, very little. It's just a tiny little LED.
Is there a way that it only like turns on the Wi-Fi signal or whatever it uses when something is plugged in? Could it like complete that circuit in some way? Because otherwise it is just, I would have, like a building designer, and I would have to calculate that 0.05 for all of the receptacles in my space.
Yeah, so the gateway, as I said, that sits on site actually is the one that talks to, it pings the individual sockets. So they're only on when the hub is talking to them, meaning that their wireless network is only being used when the hub is talking to them, otherwise it's not.
But when what do you mean by hub?
So there's a
Computer
sort of
or your server. Okay.
It's like a gateway that sits on site and it coordinates among all the different sockets essentially. So that's what locally is the brains of the system.
Okay, and that sits like somewhere in your building management system.
Correct. Or it sits on site and it talks to your building.
Okay.
But we can definitely chat more about it afterwards. Yes, Sam.
Have you considered partnering with data scientists at universities or other places? Because I imagine you must have some great data scientists, but there must be just an embarrassment of riches, and I imagine some of these data sets would be super useful for research. Have you looked into sharing?
Yeah. Well, we have an awesome data science team, and some of the work that you'll see has been the result of their hard work. Yes.
How much does the hub draw? So I have hubless monitors at our house, and each one draws a constant 10 watts.
Okay, let me, if it's okay, let me
sure.
finish Sam's question, and then I'll come to that. We have actually been working with universities as well. So Stanford, for example, there's a mechanical engineering class that we've partnered up with, and Presidio Graduate School of Business. So certainly we're open to collaborating with universities and enabling the public to take advantage of the data that we have been collecting. So, Avi, I think you had a question about how much the hub.
Yeah, so just sort of in looking at scale of each, so with these hubless monitors, each one's 10 watts, and so that's fine for a small house, but at a commercial building, that would be way too much, unless the hub draws like, a kilowatt or whatever.
Right. So a lot of our time in the last few years has been spent in modifying existing wireless networks that have typically been used in home automation type applications, and being able to apply that to large scale commercial buildings. So what we have been able to do is to essentially push the limit of how, what's the ratio of the number of sockets that a given gateway can talk to. And when in a typical residential setting, it might be, you need a hub for every 10 or at most 20 plugs. We've actually pushed that limit to 230 so far. And so for a large commercial building, we have been reducing the number of hubs that are required, and it's an ongoing process as well. So, very good questions. Yes?
What kind of loads do you see in these office spaces other than like laptops and computers? I know there's probably like a water cooler or something, but you can't really turn off a fridge overnight. That needs to stay on, obviously, and maybe the Xerox machine. But if you turn off computers and laptops, like, does that affect people's work, or is that what you're mostly doing? Because I would assume that that's what a lot of the loads are, is just computers and laptops.
Yeah, there are a lot of computers, laptops, monitors. Essentially, those are the minimum requirements at workstations. We typically monitor those loads, not from an energy efficiency perspective, but rather from the perspective of being able to provide information about occupancy and space utilization. With respect to maximizing energy conservation, typically the break room equipment, like vending machines, for example, you'd be surprised how much they draw, and they certainly don't need to be on 24/7 when the building is unoccupied. Printers are definitely a big part of that as well, water coolers like you mentioned. So you'd be surprised in every office you go, once you start paying attention, you see that there are a lot of appliances that continue to draw power, but they don't really need to.
So then when you try to make a sale to a customer, is it an efficiency sort of sale you're making, or is it, are you talking about the cost savings for them? Like what's kind of the driver for these people to like buy into your?
Yeah, I'm glad you asked that. That's a good lead in terms of what we do. So a big part of what we sell is visibility, enabling building managers and building owners to get an understanding of what's getting plugged in, who's using what, at what level of efficiency, and where are the trouble areas. So plug data really provides the basis of everything that we do, and most of our clients have, our initial conversations with them have been in the context of, I have no idea if this is a problem for me or not. Do I need to be worried about this? What is going on? I don't know. And so that's really the first layer of what we are able to provide, but that becomes the basis. So when we first started working with Stanford, for example, we had just met them when they went through a 6-month-long process. They hired, I believe, 12, was it 12, Jennifer? Yeah, I'm looking at Jennifer. They hired 12 interns. They had the IT department develop a phone app for these 12 interns. And they went around one by one, and they inventoried what piece of equipment was plugged in inside the building. So Stanford has 700 buildings. They were able to do this for a third of the buildings at most, and it took them 6 months and 12 people going around and literally just taking inventory of what is getting plugged in. No information about their energy use, nothing. And they had to then take that inventory, go look at manufacturers' labels to say, okay, on average, this piece of equipment is probably using this much. So this was sort of the state of affairs when we met Stanford, and it was taking them about 52 hours per building to just inventory for a static measure of what was getting plugged in. With our system, they're now getting real-time inventory access 24/7. Not just that, they also are directly measuring the energy use of their, what's going on in their building and the appliances inside the building. So that has been a big part of what our clients have been drawn to. But after that, we actually use the same plug data and we learn about devices, and this is in line with the question earlier in regards to being able to do anomaly detection, being able to do failure detection. So a refrigerator, for example, is a pretty standard piece of equipment to talk about because there's a compressor that runs inside the fridge, and it typically is on for about 50 to 60% of the time if everything is working properly. By looking at the patterns of energy draw for a fridge, for example, we have been able to detect fridges that are about to fail. So, for example, if the compressor starts to run much longer, you can almost be certain that either the door has been left open or that there's something failing inside the fridge, in that the compressor now needs to work a lot harder to keep the same temperature as it did before. So by looking at the plug data, we're able to essentially provide predictive maintenance for specialized pieces of equipment. And through looking at the same device data, of course, that's where we have been able to get the 20 to 40% energy reduction, and also bring about time savings when it comes to asset management. So as a case study or as an example, we have been working with the University of Maryland. Any alumni from University of Maryland? Oh, that's great. So we have been working with them in their baseball arena. So it's a mixed-use building. It has a basketball arena, but also a large number of offices. And through the use of our technology, by turning equipment off when they don't need to be on. So in the concession stands in the arena, for example, we had our automated system essentially make decisions and turn off equipment when there wasn't an event going on. And inside the offices, the occupants were the ones who were making decisions about when to turn appliances off when they weren't there. And with that, we were able to show a 32% reduction in our energy and time use for asset management. We actually just published the data and the results in Energy in Buildings. It's a peer-reviewed journal paper, so if you guys are interested, definitely check it out. It's fresh off the press. I think it just came out, so we're pretty excited about that. Going a step further, we use the same plug data to now also learn about spaces. So we looked at plugs themselves, we looked at the devices that are plugged into the plugs, and now we can make interpretations about the space and how the space is being used. So as a case study and to really drive this home, we have been working with MASTERCARD headquarters in the Midwest. They have a really relatively new building that had been designed for about 2,000 occupants, and they've been driving that occupancy much higher. When we started working with them, they were turning conference rooms into workstations because they were just running out of space, and they had assigned seating for every single person. So we have deployed our system there, looking at workstation utilization, and what we have been able to show them, and they were shocked by this, is that there have about 23% of their occupants show a consistent schedule, which is not surprising. You know, most of us just have very busy lives, and so it's not necessarily consistent. But we have applied machine learning and clustering approaches to be able to look at how the different occupants are behaving and how the workstation utilization changes. And so in the case of this particular office building, we have identified 4 different clusters of behavior for people coming in and out of the office and how they use their workstations. And we were able to show, for example, that among people with a consistent schedule, they're actually not there about 25% of the time. So maximum occupancy for this office at any given time is 75%. So 25% of the workstations at any given time is at least 25% of them are unoccupied. So on one hand, you have people sitting in conference rooms because there isn't enough space. On the other hand, you have a whole bunch of open spaces because people aren't coming in, they're working remote, they're traveling for whatever reason. And so what we have been able to do a model out essentially for them has been different types strategies for workplace planning. And so thinking about a hybrid hot desk approach would save them 30% of their space. And this has been very useful information for their corporate real estate team to be able to figure out how to fit all the employees that they have inside the same space without having to add additional. So with the same set of information, we're able to now learn about how a space is used and provide business value to them. The last bit of what we do is to look at plug data and make spaces more comfortable for people. So focusing on the people and the value that we add. With the example I just mentioned with maximum occupancy, for example, being at 75%, now let's think about the people in that space. What's going on? So The HVAC system, for example, has been set up assuming 100% occupancy during normal business hours. But guess what? At most, only about 75% of the people are there. What does that mean? If it's summertime, the AC is running about 25% more aggressively than it needs to be, more or less, just because you just don't have as much people. And what does that mean for people working there? Majority are cold because the system isn't able to dynamically adapt to the actual performance of the building, but rather it assumes a certain type of occupancy. So bringing the same data back and feeding it into, for example, the HVAC system allows us to make the entire space more comfortable, setting up set points that are that help people with better comfort and also better productivity. There have been a lot of studies that show people's productivity gets affected when they experience discomfort in one way or the other, whether it's from a temperature perspective, CO2 metrics, concentrations have been another metric of people's productivity being lower if there's a higher CO2 concentration inside the air quality. So air quality and temperature are two of the big things that we would be able to help with. So this is in a nutshell. So to summarize, we use plug data to learn about devices, spaces, and ultimately people, and help bring comfort for folks when they're in the built environment. So we're putting the plugs to work. Hopefully after this talk, the next time you see a socket, you don't think of it the same way anymore. When I look at these things, I see, okay, that's a sensor right there. It's the perfect IoT sensor that we're building and we have been making progress on. So we bring efficiency, we help with sustainability, we help businesses do better planning, we bring safety, convenience, and overall wellness. And with that, I'll stop there. That's us, Keewi. Thank you for paying attention. Thank you for the good questions. Yes.
Regarding how you use this data to change HVAC usage, is that part of what goes into your calculation for energy savings?
The energy savings we've been talking about, the 20 to 40% reductions, those have only been on the plug load energy use. With HVAC systems, as you probably know, they're, and especially in the older buildings, they tend to be the biggest draw in terms of the energy use, and having a small impact on the set points or when, the time that the AC system, for example, has to be on would make a huge difference. And it would have a much bigger impact. And those are some of the things that we're working on quantifying right now.
And have you done that with any of your current clients that try to build that into their cost savings?
Yeah, that's work in progress.
Okay.
So hopefully the next time, Ravi, we come back, we'll definitely have updates on that front with quantified information on that. So if anyone here knows of buildings that are pretty advanced and are interested in putting together, putting the newest technologies to work, especially from an HVAC system, please come and talk to us afterwards.
Yeah, I mean, maybe take a look into a software motor company. They have some really interesting technology that they're applying to HVAC systems.
Oh, okay.
They're based here in San Francisco, so.
Oh, sweet. Are you affiliated with them?
I recruit for them.
Oh, cool. Okay. Yeah. We'll definitely check it out. Don't hurt you. Yeah. I'm not familiar with. Maybe she is familiar with them. So. Cool. Yeah. Thank you for saying that. Yes.
I'm curious as to, since you've gone to the trouble of getting control capability on your devices by installing a plug, have you looked at entering the flexibility space where you can participate in demand response programs, etc., by using your plugs for control rather than just for monitoring?
Absolutely. Yeah. So we mentioned our work with Energy Australia. That has been one of the primary reasons for them wanting to collaborate with us in addition to being able to so bring machine learning-based optimization to their demand response, residential demand response programs. So once the capability and the infrastructure is there, the sky's the limit in terms of what can be done, and demand response is certainly one of the big applications from a utilities perspective. And I know that's something that Energy's quite interested in, so that it's definitely there. Maybe we'll go there and come back to Katie. Yes.
I was actually curious about the ideation behind the plug. Like, it's a very simple but clearly powerful design. And what was do you know the thought process behind it, or how you came to let's just plug it into the wall?
Do you mean from a hardware perspective, or the idea of using the plug data to do more with it?
Kind of the hardware.
The hardware, yes. I think from an ideation perspective, when Jennifer and I were first working on building the hardware, it's actually it's pretty standard, meaning that there have been so many companies that make sockets like this that, from a functionality perspective, it's somewhat standard. I'm not saying it's easy, but it's been done many, many times. One of our partners just came out, hardware partners just came out with an in-wall socket, which we've been working with them for the last 2 years on, and being involved in the design process of that piece of equipment has been really exhilarating. So for example, one idea that has been implemented in that design has been how to turn the plug on and off. So with this form factor, for example, there's a little button that you click and that turns it on and off. For that particular piece of equipment, which I don't have a sample of here, it's a capacitance. So if you want to turn the socket on or off, which also helps from a child safety perspective, if you have it plugged in, then you can just swipe it and that turns it on or off if you want to have a physical override. So there's a lot of creativity that goes into the design of the hardware for sure, and there's still a lot of room for improvement for making it even easier to use and more efficient. But probably I'm not the right person to really speak to the details of that. Yes, I think, Katie had a
I've got a double question. First one is, I'm sorry if I missed you say it earlier, but do you have a temperature and a CO2 sensor on the plug itself?
Not yet.
Okay, are you planning to have that?
That's right, yeah. So once you, again, our vision has been that the outlets themselves can, right now we're collecting energy data, but there's no reason why we can't also incorporate CO2 sensors and motion sensors and temperature sensors in the same,
Yeah,
device.
well, the sensors themselves are super cheap versus CO2, and but anyway, my other question was, have you been approaching it that all energy throughout the day is equal, or have you been approaching it differently for like peak load in summer and the usual peak that happens in like the 5 to 8 p.m.?
Yeah, there's a big difference in terms of time of use, and especially again from the utilities perspective, there's a big difference. In terms of the front end, all energy and how we communicate to the end user, right now all energy is considered the same. When it comes to sort of the back end calculations, especially from again from the utilities perspective and some of the demand charges that are involved in that, and what is the value of every kilowatt hour saved, for example, then there's a big difference.
How long before basically all new buildings, or I guess all new buildings have like smart plugs, like not just like retrofitted, but everything, like all energies that kind of routed through smart channels, and why hasn't that happened? Self-driving cars, like that seems like a pretty obvious, simple.
Yeah, that's our question too. We've always thought about self-driving buildings as something that should be achievable. and, you know, this is just my personal view on this. The construction industry is slow to adopt new technologies, and there's an inherent challenge with, you know, a lag between the time that you design a building to the time that it's actually built, and then the time that it's occupied, and then the rest of its history of, you know, 50 to 100 or plus years. And that unfortunately means that the industry as a whole is very, well, not very, but there are a lot of people who are pushing the limits, but as a whole, there's more skepticism when it comes to new technology because they know that it has to last as long as the building will last, which is 50 plus years. And so from a technology perspective, it's been available for a long time. It has been more about the adoption of new construction and the construction industry to bring that on. Building codes, of course, help, and that's usually the biggest push towards getting new technologies out. And so our hope is that with Title 24 in California continuing to evolve on that, it will push the limits and essentially requiring new buildings and new construction to have smart sockets, and that will be the way to get it inside every single building.
So that hasn't been approved yet.
Title 22 is Title 24 is in effect, and it has been in effect. So it does require that every 6 feet there is a controllable socket, but nothing about the sort of data collection side of it. We've actually been working with University of California at Davis, and the building that we have been working in is also the same building that some of the data for the new Title 24 requirements are getting collected from. So it's definitely getting moved in that direction.
Well, kind of going back to your topic of like providing valuable data to your clients, because that, like, I would say it's not really adopted because it's hard to you know, justify paying, I don't know, $1.50 for a smart one when 30 cents for a regular one, and when you're adopting that throughout a project, that is like, you order like 10,000 of those, that's a significant cost savings, right? So how do you tell your clients, hey, like, this is in energy savings, this is what you're going to get in so many years? How do you have that data already, because you're only working with very few types of buildings, so how are you going to expand your market and push toward the harder things?
Yeah, that's a good question, and I think it's something that we're working towards little by little. The aim is to be really good at a certain type of market, a certain type of building, a certain type of users, do that well, and then move on to the next one. So we happen to have started here, but of course, the potential is great to be moving in other directions as well. Good question. Yes.
Could you talk about why you feel Keewi is better positioned relative to the other alternatives some of your customers may be considering, like getting smart plugs on their own or installing a sub-meter that serves an open office area or some other combination of those options?
Yeah, well, there are options. I mean, clients can certainly, if anything, we would love it if clients were to get smart sockets on their own, because again, our biggest value add is on what can be done with the data rather than the actual collection and of it. So if buildings were to have smart sockets, then that would make it so much easier for us. So there are certainly options, but when it comes to extracting additional value and really understanding and analyzing the data, there's essentially nobody out there that's doing this.
And how do you have the conversation about the also understandable privacy issues that data collection raises, where you could potentially have occupancy patterns of each individual desk at higher resolution? Correct.
Yeah, that's a very valid point, and it ultimately comes down to the policies of the corporation. And for example, I'm not going to name any names, but one of our clients, they, when we asked them the same question in terms of how do you feel about that, their response was, this is our building, and therefore if it helps the business be able to make better workplace planning and judgments and save money, save electricity, whatever it is, then by being an occupant inside the building, you essentially you should be okay with that. But that's not how everybody feels, but ultimately it boils down to the organization and how they think of that. Yes.
Do you feel like your hardware partners are increasingly moving to the data space? Like, why don't they provide a more vertically integrated solution and capture more value from accessing that data?
Yeah, so we have been in this space for 4 years and counting, and we have been surprised that it's actually pretty hard for existing larger companies to change direction. A big part of it is not having the right expertise, but also the other part of it is really not eventually having the vision or the aptitude for it, so we haven't quite seen that. We do see a trend towards, for example, the software interfaces. A lot of the home automation type, partners who build these types of hardware, they have started to have better software interfaces for residential spaces. So that's been a trend, and that's good. We're glad to see that. But when it comes to application to the commercial space, and also then bringing machine learning and AI, some of the advanced technologies into it, we just have not seen it as much.
So what is like the differentiation between other companies in the disaggregation or building comfort space?
Yeah, so when it comes to disaggregation, I mean, people are going at it from a lot of different perspectives. There are entities out there that look at meter data, then they try to disaggregate. We talk to clients who use, our technology as well as, others, and what we hear from them is that disaggregation technologies that focus on the meter data tend to be inaccurate. It takes them about 6 months to really learn, and even then, it's not quite correct. And so we've had clients tell us that after comparing the two sets of approaches, they realize that given that the meter data is ultimately just a single signal, and you can only do disaggregation or Fourier transform in so many different ways, you're still going to be limited. So there is a need in order for those technologies to be more accurate and more effective. There is a need for bringing additional data, and the data that we collect at the socket can actually be complementary to those. Yes.
So some of the electronic devices are not super friendly to being turned on and off. That kind of decreases the life cycle. So any thoughts on that?
Yeah, so that's something that we communicate with our clients upfront. We want them to know that it's ultimately their decision if they want to turn appliances on or off. For example, we typically recommend that they don't turn off desktop computers just because you may lose some work. But then again, as a technology provider, we can't control how people use the technology. It ultimately ends up being their decision as to how they want to implement it. If that means, for them, it's a choice if they want to take that chance or take that risk.
But is there any data showing certain equipment they can be turned on and off, I don't know, more than 10 times a day, or have you guys looked into that?
I guess depending on the type of appliance, those are some of the things that the hardware or the device vendors themselves may have. It's a lot of times not publicly available, so that makes it a little bit challenging. But again, we leave it to the user to decide, the end user to decide what they want to do about it.
To go back to the building codes and thinking about that, have you explored having regulatory people that are talking to the regulators and saying, hey, we need to get these in buildings, and hey, we have good technology to measure performance and measure energy efficiency?
I wish the answer were yes. Again, we're a small team with small resources, but that would be the way to go there. We have been working with industry sort of, I want to say networks, for lack of a better word, who, excuse me, who deal with the regulatory side of things, but it has not been as big of a focus for us just yet. But hopefully soon.
Give you a nice baked in, you start to get that locked in aspect to your technology, and that's pretty nice.
That's true. Do you know anyone in the regulatory space?
You know my co-founder, Porter, right? From eGrid, he said that he had met you. People from Opower. So I have a history of Opower, and they have a long history of getting energy efficiency into regulations across the U.S.
That's
pretty valuable.
Yeah, it'd be interesting to learn more about that, for sure. Yes, go ahead.
What do you charge?
I'm sorry?
What do you charge?
Yeah, like we mentioned before, it's essentially a subscription. Depends on the scale of the project, meaning, on a per plug or per user, per month basis, it changes how many users you have. And
what's an average case study you think? Like for any of the sites, what would I expect to pay?
Yeah, we typically do small sized pilots, anywhere from $5,000 to $25,000 depending on the scale.
Is that a yearly subscription?
That's for an initial pilot, because for an initial pilot, our team does all the installation and everything, so it tends to, but over time it ends up being about $5,000 per building in the long term. Of course, it depends on the size of the building and all of that, but that's about the scale.
And that subscription covers all the equipment, right? Like the sensors, labor, everything is included on that subscription?
Depends. So some clients would rather use CapEx to buy the equipment up front, so we allow for that. So in that scenario, it wouldn't include that. But in other cases, they would rather lease it over time. So it really varies.
So you provide both financing and an upfront hybrid model?
Correct.
And is that $5K with the full financing included, or is that with the?
That's without it.
Okay.
Yes.
Right now, how much human interaction is needed to get these savings and the comfort solutions, and when you expand to having any companies using your product, do you see this level of quality going down because you can't provide that human component?
Do you mean on our side?
Can you repeat the question?
Oh, sorry, I've been forgetting to repeat the question. Okay, so the question is how much human interactions there are and whether the quality of the service and the product that we offer, you would expect it to go down because we're not able to, provide as much of a human touch point.
Example, where we're able to see that 75 points and 10% of the space is being used. I feel like that's something that you would have to go into and do it just to show that, this is what's happening, but if the business expands, you might not be able to do that.
Oh, I see. So the question is in relation to the case study we talked about with occupancy. So that information is readily available. It actually doesn't require us telling our customers about that. So by going to the interface and looking at reports, that's something that's automatically generated in the background. So that's where the data science part of it comes in. I'm not the one to talk about, but it's essentially automated at this point. Did you?
I did, yes.
Yes.
Your comment about self-driving buildings, I'd be thinking of Mark Andreessen, who did the software feeding the world stuff, now saying that it's programming the world. And you mentioned that for Maryland Stadium, that the tool will make decisions about what sockets to turn on. Are customers anxious about transferring some of the decision-making capacity to the software to make those decisions? And is there a feedback loop to say, oh, we actually wanted this to be on at this moment?
Yeah, the question is whether there are, if the end users are anxious about allowing the AI system essentially to make decisions for how their building is set up, or specifically, I guess in the case of Keewi, whether their sockets are turned on or off. We've been doing a lot of user research on that, and it's actually a pretty mixed bag. Some people are happy to not have to think about this, and they ask for things that make it easy for them to do the right thing, and that's a quote. And there are others who would rather continue to have full control. So with that in mind, we do have essentially built-in feedback system where if a user does a manual override, meaning that they manually turn the plug either on or off at any given time, that's taken as feedback into the AI system so that it knows what the user wants, and it builds that into the rest of its predictions. Yes?
I'm curious, how much do you integrate with the existing BMS in the building? Like do you have the data as input in your model?
Yeah, the question is how much do we integrate with existing BMS? So our perspective has always been that there is a great need for building systems to be integrated. So on our side, we've already developed APIs that allow our data to be transferred into existing BAS or BMS, and it really will depend on the other party, whether they'd be open to receiving the data. But on our side, we definitely have a big appetite for collaboration.
And then how do you find that communication is going? Is it challenging to communicate with the BMS protocol?
There are standards that have been put in place that make that a little bit easier, like BACnet, I'm not sure if you're familiar with that, that make it a little bit easier for different systems to talk the same language. For us, a big part of what we do is to be able to send the data to an existing system, and so when customers are interested, we make that happen on our side. All right.
Thank you so much.
Thank you.